Hello there, Mr. Sutton, bringing you our first lesson on inequalities in lines. This one will deal with simple inequalities. We're going to be finding and graphing solution sets of simple single inequalities. And the real life payoff for this, we're going to figure out how many bricks we can safely fit on an elevator. For the warm-up on this lesson, take a minute to pause the video and write down everything you know about solving inequalities. Let's go ahead now and solve this inequality together. First step we need to do is get the x by itself on the left side of the inequality, and this is important as we'll see in just a little bit. Now, as you're rearranging things algebraically, most of the time you can keep this inequality facing the same direction when you move things. The only time you have to reverse the direction of the inequality, maybe you remembered this, is when you multiply or divide by a negative. So here let's do a few steps. Let's subtract the 4 first. That'll give us negative 10 over on the right. And then subtracting 9x gives us 2x on the left. Notice that we have not multiplied or divided by anything yet. We've just subtracted and added, so we don't have to reverse our inequality. Now we're going to divide by positive 2. Now it doesn't matter that we're dividing into a negative or a positive. Either way, if you're dividing by a positive, you do not change the direction of the inequality. So that's going to be x greater than negative 5, and that's the solution set, but we also have to graph it. So to graph this thing, we're going to first plot the point negative 5 on a number line. So let's draw a number line here. Now, when you're doing inequalities, you have a choice between open and solid or filled in dots. And the difference here is if you have less than or greater than with no equals in the inequality, then we're going to use an open dot. It's kind of just a fence, a boundary value, but it's not actually part of the solution. Versus if you have the equals in your inequality, then we would use a solid dot to show that this point is actually part of our solution. Here we've got x greater than negative 5. Negative 5 is not actually part of the answer, it's just a boundary value, so we use an open dot here. Next, and this is why we wanted the x on the left side, we're going to shade in the direction of the inequality if x is on the left. It works out very nicely that if x is on the left, whatever direction this arrow is pointing just tells you which way to shade. So in this case, we would shade to the right. Now, if you think about this, what this is actually saying, this is saying our solution is all the x values that are greater than or to the right of negative 5. And that is everything we shaded here. But if maybe you don't trust the little get the x on the left and follow the arrow trick, you can actually check your answer by testing a number that's in the shaded region. So for example, 0 is over here somewhere. So if we plug 0 into the original inequality, it should make it come out true. So we can write 11 times 0 plus 4 greater than 9 times 0 minus 6 and see if that's actually true. This just zeroes out, so you have 4 greater than negative 6. That is true, so that proves that we actually did shade the correct side, and you can always test your answer. Let's see if we can use inequalities in a real-life setting. Let's say we have a freight elevator of a building, and we're loading bricks into this elevator. We can safely carry a load of at most 3,000 pounds. A worker needs to move bricks in 50-pound stacks, and let's see, the worker weighs 150 pounds. The cart she's using weighs 300. How many stacks of bricks can she move each trip? We want to move the max possible, right? We don't want to be taking unnecessary elevator trips. So take a sec, see if you can set up an inequality to describe this situation. Okay, now that you've paused the video and set up an inequality, let's see if you got the same thing as me. So let's have a variable in here. Let's let x be the number of stacks of bricks. You can use any letter if you want. And writing our inequality, we've got the 150-pound worker, plus another 300 pounds for her cart, plus the weight of all the bricks. Now remember, each brick stack is 50 pounds, and there are x stacks of bricks. So if we multiply those things together, 50 times x, and add that over here, that gives us the weight of all the bricks. Now we said this has to be at most 3,000 pounds, so it could be exactly 3,000, or it could be less than 3,000, so less than or equal to 3,000. Let's go ahead and solve this now. Pause the video and make sure you do it correctly because we don't want this to happen. Oh no! All right, Now that you've had a chance to go ahead and solve that, let's see if we came up with the same answer. This will give us 450 when we combine those two numbers on the left. Subtracting that over here, that'll be 2550. And if we run that on the calculator, maybe you can do it in your head, that's going to be x less than or equal to 51 stacks of bricks. And let's go ahead and graph that now. Maybe people don't know what this means, so let's provide a visual. So we're going to have, because we have the equals here, that is a solid dot on 51. And we're going to go to the left. X is on the left, the arrow's left, we're going left. We're going to do two more examples just to make sure you've got the mechanics of solving these things down. Go ahead, pause the video, and try out this third example here. All right, let's see what you came up with. So first thing we need to do, it's a good idea to simplify both sides of an inequality before you move things from one side to another. Here, we see that we have a negative and a parentheses. That's a -1 getting distributed here. Make sure you don't accidentally multiply by 30, right? So that'll be 30 minus 12 plus x. Now the question is, do I have to reverse this inequality? I do not. I'm not multiplying both sides of the equation by a negative. I'm just rearranging things on one side. So if you're not changing both sides of an inequality, you don't have to reverse the inequality. So that's going to be 18 plus x. And then the easiest thing to do here would be to subtract x over to that other side, giving us 6x. Still haven't needed to reverse the inequality. Next step, we can divide both sides by 6. That'll be 3 less than x. And at this point, you might be tempted to go ahead and solve, or rather graph the thing. But we got to be careful. What this is saying here is 3 is to the left, that's what that means, to the left of the solution. So if you were to go ahead and graph this just following the arrow, you would actually be going the wrong direction. We want to make sure that x is on the left side. So if you reverse this to get x on the left, make sure your inequality is still pointing at the same thing after you reversed it. So here we're reversing things. Notice I'm still pointing at the 3 down here, just like I was up here. And now we can go ahead and graph that. So we've got open dot on 3, graphing it to the right. Take a moment to try the next one on your own. All right, so the beginning on this one is a little bit tricky. We have to multiply both sides by -5 to get rid of this fraction. Now, when we do that, right away, we're multiplying an inequality by a negative, so we have to reverse the direction of the inequality. So that's going to be positive 5x minus 15 over on the left side when you actually go ahead and distribute that. Then let's rearrange things here. We can move the 5x over to the left and the 3 over to the right. So we'll have a negative 18 over on the right and a negative 3x over on the left when we subtract 5x. Now we have to divide by -3. And since we're dividing by a negative, we again have to reverse that inequality. So instead of being greater than now, this is going to switch to less than. X less than positive 6. And that's another open dot going to the left. Now you might be thinking, well, wait a sec. 2 reversals, if I just ignored all this stuff and didn't reverse at all, I would have ended up with the right answer. And you would have, except that your work would have been wrong, and your teacher probably would have taken some points off for that. 2 wrongs do not make a right. That's it for this first lesson on inequalities. Watch your dots, watch your shading directions. This is Mr. Sutton, signing off.